Solving proportions. The definition of a proportion is essentially having one fraction equaling one fraction. A lot of times they'll talk about having one ratio equal to another ratio. If you were scaling a model or something along that line and you said that you had a 1 to 25 ratio, it's written as a fraction, and you would say, well, what would the ratio be if it was x to 100? In other words, it's something that was 25 centimeters long. How would that look if it was elongated to 100 centimeters long? Most people teach this as a process where you cross multiply. I don't like to cross multiply, but I'll show it for this first idea here, and then thereafter I'm going to show you the algebraic concept, the way it should be done. So if I cross multiply here, you go bottom times top, that would produce 25x, bottom times top equals 100. And then you have to divide by 25, and we would find that x would be 4. Now if I put this 4 back into the original statement, we see that we get 4 over 100. Well, 4 over 100 reduces to 1/25. That's why we say that a proportion is one fraction equal to one fraction. Your end result is just a scaled version of your original fraction. Now I'm going to jump right into a more advanced problem. In algebra we'll probably see something that looks like this. X plus 3 over 2 is equal to, let me just go ahead and put another one over here, 2x minus 1 over 3. Now it's true that you can cross multiply. You can go bottom times top equals bottom times top. However, I like to go back to the concept of what I've taught you when we run into fractions. We always get rid of the fractions. We kill the fraction. And so when I look at an equation like this, I know that I have a common denominator of 6, and I prefer to solve all equations using the same method. I'm going to multiply by 6. As I multiply by 6, I recognize that this can divide, so I go 6 divided by 2 is 3. Numerator comes straight down as x plus 3. In a similar fashion, as I go to the second fraction, 6 divided by 3 is 2, and the numerator comes straight down. Now I want to solve this equation, which is much easier to do. As I distribute, I get 2x, 3x, plus 9. 3 times x is 3x, 3 times 3 is 9, equals 2 times 2 is 4x minus 2. Now from here, we use our techniques for solving equations. Do you want to move the 3x to the 2x? Hopefully your response is, let's move that 3x over. If this side is going to be dedicated to variables, that negative 2 needs to get out of there, so we'll move it across the other direction. And so I can rewrite this as 9 plus 2 equaling 4x, this comes over as minus 3x. So 9 plus 2 is 11, equaling x. So you got an x equal 11. You could plug this back in, check that you get the same proportion, that this side of the equation is equal to that side of the equation. But essentially, our work is done here. We've solved the equation.